I'm going to try to focus on drilling down today on enterprise blockchain, which is really about communities. It include communities like UCI, communities like Citibank, and communities like ACM. Any number of communities could be viewed as an enterprise, but the idea is you're serving a community of members and you're trying to deliver blockchain type solutions. So let's launch into that, talk about what's been shown so far. I think it's important to know that we're in the early innings of blockchain development. People are going to try to convince you that the leaders have already, the die's been cast, but in real life things are going to happen a lot differently than we imagine, and we're probably in about the second inning here. Okay, so what are we looking at here? It's an area that's been hyped and ridiculed. People think that they can just deliver trust out of thin air, and at the same time, it's very confusing to most people. It seems very exciting. And so what are we really looking at here? You're looking initially at Bitcoin, and let's just establish what we're seeing with Bitcoin and what we're not seeing. So with Bitcoin, it's been running for about 10 years. There's a few things that people don't necessarily know. So Bitcoin runs on top of what I'd regard as a fairly standard database called LevelDB. Most of the piece parts are all known and something you'd see in any computer science department, but it was a very clever system. What it does not do is what you would call a real double entry transaction. And so when two people are moving Bitcoin, there's presumably always a counter transaction that's hidden. And that's not how most enterprise systems work. So what have we learned from Bitcoin? Bitcoin is a tremendous proof of blockchain. And we're not going to really focus on it once we move off tonight, but I think it's critical to understand what happened here. And it has some important implications for corporations. And so if you think back, Bitcoin's been running for about 10 years now, but it all came around, like a lot of human progress, through the stipulation of an assumption. And that stipulation is that the tallest block of Bitcoin transaction, like a stack of Legos, is the right block. I think that if you thought about it hard, what you'd realize is this is a statistically based solution. Once in a while, the wrong transaction goes through. And once in a while, quite often in fact, the right transaction is just churned in the memory pool for an extra 3 cycles. But we've all agreed, if we're playing the Bitcoin game, every 10 minutes on a single version of the truth. There's a winner, that miner is winning, he's got the single best version, and we replicate from there. The challenge, which we're comparing to, is in modern corporations, they haven't had a single version of the truth in 30 years. With Bitcoin, it's all about getting everybody to agree on a single version of the truth every 10 minutes. It's the latest in a long line of these financial computing innovations. Some of those we weren't around for. We talk about clay tablets. The real genius of that era was the guy who invented the quipu. It was the first decimalized computer. They used colored cords to set up natural accounts and liabilities. Permanent storage, obviously, with those knots. And it was the first distributed database. So throughout the Incan Empire, they stationed every 20 miles a station to update the quipu, and they would have runners run up and down the highways, running up these things. And it basically kept track of how much labor and buckets of corn you owed the emperor. Roll forward 4,000 or 5,000 years, you've got Paciolo Summa, double entry bookkeeping, and really that was a big, big event. And blockchain is in some respects just a reset of everything that Luca Pacioli sort of outlined 500 years ago. The modern era started just a few years ago on the campus at MIT with Whirlwind. And that was real-time computing, parallelized logic, magnetic core memory. And then Jay Forrester moved across the street to the business school and told everybody that if you're going to have real-time corporations, does anybody remember this story? How many times a week did he think real corporations should crank their numbers? 27 times a week. So Jay calculated that in order to knock down those third-order problems, you had to re-crank your computer at your corporation, reforecast 27 times a week. He said that in 1954. How many of your companies out there, Yoke Tanaka, are re-cranking your forecast 27 times a week? So think about it, it's a different world, but we've been working off this 1951 computing paradigm now for some time. So what is blockchain really doing when we think about this? You're basically taking my planning, your planning, multiple parties are coming together, and the thing is that unlike relational, where once you're inside the database for the most part, you've got free reign. We had row-level locking a few years ago, but it's not cell level yet for most people. Blockchain is really all about cell-level locking, going in there, you and I, and having a transaction, jointly executing. With blockchain, it's a joint execution. You're agreeing jointly on a smart contract that you're going to abide by, and you have an agreed settlement. So, now we're ready to talk about enterprise a little bit. What are we seeing in terms of important distinctions here? First one is public versus private. Public versus private is all about whether the data is commingled amongst a variety of different communities. If a single community, a single sponsor is basically holding the data and only its members can see it, that's a private blockchain arrangement. Public blockchain is where you've got an open, winner-take-all, anybody can come in and put stuff in. So in Ethereum, you've got CryptoKitties next to other things, and it's a terrific model if you want to take advantage of the compute power. If you're a little more worried about your privacy, then there's a question there. Some people don't want to commingle their data in the enterprise. Second thing, which is related but not the same thing, these two things are often conflated, is how is the membership managed? Is it what they call permissioned, or is it open? Any blockchain system can be set to open mode. Doesn't matter what it is. If you let everybody in, then it's by definition not a permission system. Most of the bigger corporations and regulated entities are looking at some sort of structure where there is a permissioning. Why is that? Because clearly they believe that there's a certain membership component, there's a certain risk to the addition of every member, and they want to vet that person in some way. And in many cases, their regulators asking them to do so. And then the final distinction that we could draw is how does the network's costs get managed? In one case that we talked about with Bitcoin, it's bounties, where the miners get a coin or something out of the system, they're supporting it. And everybody who's a member of Bitcoin is probably committing some sort of compute time with that. And the other option is a standard model where the costs are borne by subscription. So the final thing I'll mention on these variants is on-chain versus off-chain. That's a real hot button for performance and a hot button for companies that are trying to comply with regulations. And so the question is when you've got a transaction, what do you put on the blockchain and what do you put a pointer to another system? And how do you know that the item that you're pointing to is staying the same? I mean, you typically use some kind of hash to make that happen, but net, it becomes a more complicated system, but you get the more performance. In the stock market, typically you would have ticker symbol, price, and shares. Everything else is held off the transaction chain. But in other fields, most people are used to having everything together. That's a real problem for blockchain because the performance, as you're tagging on all this stuff, gets slower, slower, and slower. For those of you that are still trying to visualize what this should look like, I would encourage you to think about cash register tapes or stock tickers, thinking about how the blockchain should look. So when you get a cash register tape at a dime store, at a dollar store, it'll have each of the items and the price, but it doesn't necessarily have your name on it and a lot of other transactional information. Okay, so we've talked about these different flavors. How would we map them out today? I've just picked out 3 popular ones. On the right, you've got Bitcoin. Positioning is more classic. Governance, not really sure. You know, you've got Bitcoin's core development team. How many of you know who they are? Okay, that's 2 of us. How do they make decisions? Well, they often get on the phone, talk to people. Bitcoin, to my knowledge, made a big decision. They had so much trouble delivering Bitcoin 1.0 that they got together in Rome last year and they canceled it. They're going to skip right to Bitcoin 2.0. So they're still on, I believe, Bitcoin 0.8 as a versioning. So it's on the governance side, they've got some work to do. On the uptime side, they've done great. They've got open participation. They've got a terrific consensus model. Problem there for them is they're using more electricity than the country of Ireland to support their notarization. Ethereum, again, not as clear how the governance works. You know, does Buterin make all the decisions? Is the foundation making the decisions? We're not really clear. It's more of an open system, but it's being carved out with velvet ropes by people like Quorum. They're making a move on the consensus model to proof of stake over time, but they've got a terrific smart contract system, and they're really making, it's a very robust community, a little faster than Bitcoin, and they've done an awesome job supporting all these new ICOs. Finally, in the middle, we've got Hyperledger Fabric, which is more of an enterprise-grade model supported by the Linux Foundation. IBM is big there, along with Cisco, Oracle. Everything is a little bit more transparent, and it's more of a plug-and-play model. So it's 17 individual components. You want to pull out the traditional notarization scheme and put in Raft, you do it yourself. You want to pull out something, put something else in, you can do that. But it's currency free. So again, if you're a cryptocurrency person, it's not very exciting. All right, so what's going on the enterprise side? Everybody wants to talk about enterprise coming into blockchain. What's really happening in enterprise, and how do we know? The trick is this. So we all know, if you're older, that relational hasn't been around forever. But enterprises went hard into relational in the 80s. The problem was that we had a profusion of databases that didn't agree. And so about 10 years ago, corporations started talking about big data. And big data is a euphemism for saying, I've got too many relational databases and I can't figure out what the truth is. And when you see Python, and that's the little Python logo there, and I ask, anybody who's working on Python is probably in a corporation or in a group that's admitted we're overwhelmed and we can't use SQL anymore to find out what happened, right? But if you think about the traditional data models in the enterprise, you know, do people remember OLAP versus OLTP? Does that ring a bell? So basically you had your OLTP, which is your transaction database, and you mirrored it over to your OLAP database, right, to analytics. That whole side has now gone over to big data. What happened to this side, the old transaction side? Nothing. It's still, for the most part, stuck. Wall Street claims they're ahead. How do we feel about that? Well, in real life, Wall Street, again, has spent a lot of time on algorithms, which is a lot of this analytics side, and a lot on high frequency. But in real life, when they transact at a femtosecond level, it's still taking 2 days for them to settle that trade. So the front end is fast, and they're doing an amazing job. The back end hasn't really changed much in the last 40 years. Okay, it's a tricky thing. So where are we on the enterprise world? We say you've got feet in relational concrete and your head in big data. That's where they are. And so what's the possible answer? The possible answer for them is to bring blockchain into that OLTP side and to try to get a single version of the truth. And who's running in there? Well, you've got Linux Foundation, IBM driving Hyperledger, as we spoke about. You've got Amazon, IBM, HP, Microsoft, everybody styling themselves as blockchain as a service, where they're going to, again, coming back to our example, you're going to publish your smart contracts and your membership to their database. And then you've got the financial services companies rolling in. We got some pioneers there, JP Morgan and Northern Trust, and we got some standalone. So there's a lot going on I'll take the position that all of us are challengers. It's very, very early. Most of these people will get up and show you a really sexy proof of concept, but there's not necessarily a lot behind it yet, and we're all guilty of it. So how does an enterprise move incrementally into this space, and how do you work to become blockchain ready, and how do you gradually move towards this and believe in it? So the answer is, like most things, you don't have to believe in blockchain to take the first few steps. And so the first two steps really are, and the most important one is a shared data model. So if you, in your community, in your industry, can have a shared data model, you're ready to transact in blockchain. But even if you don't get to blockchain for 5 more years, it's a tremendous benefit for the entire industry. So yesterday I was in New York City with Merck, Novartis, Biogen, Pfizer. What do they want to do? They want to have their clinical supplies for clinical studies come to all the UC hospitals and come together at the right time in the right place. So UCLA has got 690 clinical studies that they're trying to find out if new drugs are working or not. 40 of those studies might be from Pfizer, and 20 of those might be from Biogen. So Jess DeJesus, who's the chief pharmacist at UCLA, gets 2 pallets of clinical drugs every day. Life or death decisions are being made. It's all on paper. They show up, and he's got 690 invoices that he's got to sort through. Every clinical study has an active and a control, and so that they're double blind, guess what? There's no writing on any of them. So he's got 1,400 drugs that just have barcodes, and 80 of those are associated with Pfizer. But some of them, if you open up the thing, say Merck on them. Why? Because Merck is the comparator drug. So they buy the drug from Merck to test against. How does Jess keep track of this stuff? Great question. But his goal is to get all the way down to step 5. But the first goal for Pfizer, Novartis, Merck, and all these other drug companies is to have a shared data model. So every Wednesday morning, we all get on the phone and work through how many digits should be in a tracking number. You'd be surprised how many industries haven't ironed that out yet. So again, for point 1 and even point 2, shared client, which would be Jess's iPhone app to scan his drugs with, we want that whether we move to blockchain or not. Then you've got the idea of moving to a shared open system, as we've talked about, where, say, Pfizer, Merck, and Novartis all participate in the same blockchain, and they put it out on, say, Ethereum, or a shared permission system where they work with, say, an industry body to try to make it all come together. They've got more control, less flexibility, and an opportunity to upgrade then. Or a shared permissioned and partitioned system. This is a new concept. We're going to flag that as a new concept area. Partitioned is where the database, you've got Merck, Pfizer, Novartis, UCLA, all working against the same blockchain, but they can only look and talk to the cells that belong to them and communicate privately amongst whoever is a party to that. So partitioning is another thing that blockchains can do. This is the process flow to set up a blockchain today. It's a lot of work. You have to get, as we talked about before, your stakeholders right, like UCLA and Merck and Pfizer, understand their requirements, understand what kind of events and call-outs they need in addition. So if you've got one guy who's ready to do a transaction in blockchain, how does the other person know that he's supposed to log on and do it? Right? Today on Bitcoin, you two have agreed to buy or sell a bag of weed or a pizza. You already know that you want that pizza. It's easy to then sit down and hash out the Bitcoin. But if you're Pfizer and you've got 220 clinical studies, which each have 40 sites, and they want to know if the drugs reached UCLA or not, they would like to have an event notification. We then have a design studio, figure out the members, due to the data science. That's all about this we talked about a minute ago. But then, do you put it on-chain or off? And then how do you set up the infrastructure to make it work? one of the most important pieces at the bottom is not an afterthought, which is this business intelligence piece. The important thing in the business intelligence side is you've spent all this time and all this money getting the security right. So the trick is you need a very symmetric model. Whatever you're promising your customers is going to be your security has to be your security on the back end. And so you've got to make sure that people understand what's going to be encrypted on the chain, what's going to be decrypted, how you make that work. We picked the pink boxes because that's where you need to start. So you basically, if you can't get your data science and your transactions right, you really can't build the system. It's not a blockchain-ready system if you can't iron this part out. Blockchain is really a transactional system. If you can't define the transactions, it's just a data store. So some enterprise use cases, global supply chains are a hot button. Private transactions, patient records are a biggie. Anything where privacy is involved. I saw that you guys had machine learning and all these other guys in the last couple of months to talk. Anybody who's invading your privacy with machine learning, you'd like to have a blockchain in front of them to give them the permission to do it and to give them permission to do it just for a little bit and forget it. Let's talk about that runtime. We talked about where these pieces are. So the question is, how do you define your membership? What transactions are allowable? How do the events work? How do you gain consensus? And then you have the blockchain below it. On the side here, encrypted data is stuff like your personal information that you don't want on the blockchain, right? You can't just have it out there in the open. And syndicated data is stuff that would clog the blockchain. So coming back to the Merck and Pfizer example, the medical guide, the little black and white thing that's inside of every pill bottle, that can be the syndicated data. There's no reason to put that on the blockchain. Every Viagra bottle has the exact same one. So let's talk quickly. So far, what have we built up? We've really built up what I would call a runtime model. And the question is, how did we get where we were? And the answer is that inside of a enterprise or a community of enterprises, what you have to put together is a whole membership model that enables you to permission people to join and to tier them with the right level of permissions. That's really the critical distinction between the older first-gen blockchain model like Bitcoin, where they were encouraging everybody to join, and the newer model for enterprises where JP Morgan only wants to have JP Morgan employees coming on board, and then they want to permission them according to their role. And so the idea there is that the sponsor in this case would be JP Morgan. They would use the Fabric certificate authority to set things up, but they have the opportunity in many cases to use what we would call off-world credentials, LDAP or Microsoft Active Directory, use an OAuth 2.0 token and get yourself in that way. Is that less secure than using the system's own certificate authority? I would tend to say yes, but everybody's got to make their own decisions when they put their security overlay in. They can figure out their security leadership on their own, right? All right, so we've talked a little bit about how that works. Where's all this heading? That stuff is working pretty well today. These are what we see as some of the big issues that people are looking at. Chain code portability, blockchain federation, where blockchains are talking to each other. It's a hot button. So let's say you've got a blockchain that's doing the drug supply chain. How do you get the financing for that if you're a middleman? Can you open up your blockchain to somebody who's going to provide working capital loans? Let me tell you, there's a line out the door to do that kind of thing. Because now, if you're familiar with sort of what are called credit enhancement techniques or something like that, when you're moving from an unsecured loan to a secured loan because they know for sure that those parts are there, that's a huge gain in terms of what you pay for the cost of money. So you can imagine that Airbus and Bombardier are very excited about this, as would be the airlines, because they all maintain huge quantities of spare parts today that are very expensive, but they can't really get a secure loan against them. With blockchain, they'd be able to do that and securely hypothecate those assets. There's not a person that we've met in the enterprise world that's not interested in hypothecating their assets. Getting more robust models for organizations from permissions that we just talked about. Analytics on chain code data, just getting started. We've met the first bank that is actually pulling it down to Excel. Next-gen crypto and data models. How many people have been talking about quantum? It's all a hot button for everybody. You know, clearly you've got to stay a step ahead, and you've got to figure out how you're going to always be ahead of the next person on the crypto side. And the biggest issue is this. When you've got a homogeneous blockchain, and every record is worth 30 bucks, and it costs the bad guy 30 bucks to break open that cell, it's not a good trade for him. But when you've got a chunky blockchain with certain, you know, you've got Bill Gates' checking account in there with mine, you know you've got one really great checking account that's really worth breaking open, right? And so how do you do that? Any ideas? Well, the first thought is to chop it up into little pieces. It sounds easy, but that's called identity mixing or muxing. That's a classic blockchain technique. But the idea is try to figure out ways to do your data modeling so that no individual cell is worth that much, and then try to stay ahead of people on the crypto side. It's going to be harder and harder. Big issue for enterprise is integration with enterprise systems like ERP and MES. And you can obviously think about the implications there. Right now, in Bitcoin, the presumption is most of the people who hold Bitcoin wallets are what? People, right? What we're going to see in the enterprise world is a bunch of wallets that are actually held by machines. And how do you secure those appropriately so somebody's not snaking into the SAP system to wiggle the wallet? And then finally, probably the #1 hot button is compliance with privacy laws. Anybody in the room been talking about GDPR at their business? Huge, huge, huge issue. And if you're a computer scientist, it's a very troubling issue. You know, how do you do a backup in the Cayman if you're not, you know, if you don't want this data to get out, if you got somebody has a right to forget there? You know, it's a very, very tricky issue. And so it's going to be a big, big issue in terms of this off-chain, big issue in terms of how you do your backups, big issue in terms of how you set up your orgs. All of these things have to get ironed out. GDPR is just going to be a major, major pain. But it's going to be even worse when we start seeing whole genomic data out there floating around. How many people have been following the Golden State Killer case? So this guy obviously got caught. He was a serial killer because his relatives posted their DNA, and they had his DNA sample all these years, and he had enough nieces and nephews put their DNA up on site so that they were able to catch the guy. Well, I think it's terrific that they caught him, but if you were his niece and nephew, you might not feel so great. And when you start having to pay 3 times as much for your auto insurance because you've got an aggressive gene or something else, it's going to be a very, very troubling situation. So again, where's this all going? It's all going towards blockchain as a front end to artificial intelligence, deep learning, Internet of Things, combining to make every transaction instantaneous, trackable, and if the blockchain works, confidential and unforgeable. So that's where we're headed.
Ben, very quick question. The video went so fast, I may have missed it. So where was that part you have the consensus building in all the data capturing?
Yeah, so as he said, he referred to it as the magic of blockchain.
Correct.
And so behind the scenes, and again, I don't want to lose people, but essentially you have what's called an orderer, which is a Kafka or zookeeper piece, which is basically coordinating and sorting the orders. You think about it as sort of building a Lego, and then they're checking against smart contracts. And then the big thing is, you're not supposed to be signing off on your own transactions. So we always try to set it up as a minimum of 3 notarizers. And so that way, if 2 people are a transaction, there's a third person who's there to sort of notarize. They check everything, and if it works out the way that it's supposed to, then it's clean.
So those are just like a miner's equivalent, so to speak?
Correct. So you're basically doing your own mining as a group of 3. And then the idea is the way that everybody has a slightly different model. In Hyperledger, we typically show we don't block the bad blocks, we actually include them in the block, but they have an X through them, basically. And so you show the bad ones and the good ones, and they all get stacked. In some of the other systems, the bad transactions just sort of slosh around in the memory pool, along with things that didn't get notarized. If you've got 200 servers running, that's enough to do the entire drug supply chain in America, no problem. It's not enough to do the New York Stock Exchange or the foreign exchange market in an adequate amount of time. So blockchain's not ready for what we would call prime time on Wall Street, foreign exchange. It's not quite there yet, but it is there for something like most of the physical markets, like say drug supply chain. I think we're looking at about 14,000 transactions a second for the US pharmacy market. It's not really that much by modern standards. Sounds like a lot, but it's very doable. So that's kind of the trick. So again, if you're looking to do that in 2-second response time, 3-second response time, you're in pretty good shape, which is up to people's expectations. For the stock market, where people are looking for femtoseconds, not going to happen with blockchain today. Another question?
Yeah, so from a business case perspective, what do you see as using blockchain and really solve fundamentally versus a centralized platform?
Yeah, so what I would say is that it's a good question, but it's a bit of a false question. So there's certain blockchain applications where you want a high level of database distribution, and others where you're using blockchain, but it might only be 1 or 2 instances of that core database at work. And what you're really using the blockchain is for the cell level encryption and cell level access. And so distribution, it's a very, I saw one of the biggest asset managers in the world a couple of months ago, and they had stuck in their head that every one of their customers was going to get a full copy of the database. No, you're going to have one in Boston, one in Seattle, and you're going to keep an extra for the SEC if they have any questions, one in London, one in Hong Kong, and you're done. You're not going to have everybody who's accessing your system with a full copy of the database. It's not necessary, it's not desirable. For Bitcoin, it makes sense, and for other systems, it makes some sense, but as you know on Bitcoin, anybody's familiar with the Merkle tree model? Yeah, so they have to continually sort of chop it down to size so people can put it down. That really is not smart for Wall Street or supply chain.
One is using ERP, MRP systems. One of the features they really emphasize on is running planning. So how is this blockchain's power when it comes to predictive standards?
Yeah, so what I would say is that what we expect to see is a couple different models. So if you think about that traditional supply chain world, let's just talk about a couple of things. The first thing I'd have everybody think about is you've got the transaction plane, you've got the control plane, and you've got the risk management plane, right? And so essentially, the question is where are you going to use blockchain? You could use it at all 3, or you might just use it at the control plane and the risk management plane. So what you're talking about when you're talking about planning in the supply chain is you're really working in that control plane and risk management plane, not at the transaction plane. And that's where the MES guys can talk about till they're blue in the face, and you just want to throw them out the window. Because essentially what they're talking about is what's happening inside the 4 walls of your plant. And the respectful answer to that is, who cares? So if we take someone like a big drug company, when we meet with them, do you want to take a guess? For a big drug company, how many drugs out of 1,700 SKUs are out of stock at any given time? Anybody want to guess?
40%.
Yeah, it's a high number. 350 drugs are out of stock. Is it an MES mistake? No, their MES system is perfect. They know they sold 1 million doses last year. They made 1 million doses this year and a little bit of safety stock. But all of a sudden, the phone starts ringing. And why? Because more people got the flu. More people felt they had a herpes. Who knows? All of a sudden, they've had a spike. And unfortunately, they've got a lot of Spanish inventory and no French inventory. None of this is inside the MES system. None of this is inside the ERP system. They're losing, I know a pharmaceutical company that's sitting on $780 million of unfilled purchase orders. Do you think they're happy about that? No. Why is this the case? Because they can, FDA only lets them make this drug in 2 plants around the world. So the whole point is to be able to load this up from the MES system, load it up from the ERP system, and get an entire look at the entire supply chain. And why are people going to be willing to do that? It goes against the interests of the middleman, and nobody really wants to share data. But when you can share anonymously and chop it up into pieces and see the whole supply chain, it's a big win for everybody. Because again, the middleman doesn't want to let everybody know how much safety stock he's got. He doesn't want the Pfizers and the Mercks to know that at the end of the quarter he's running out. He wants them to feel like he's doing them a favor by taking that extra pallet. And to do that favor, he wants a 15% discount. Right? So blockchain's a big threat for people like that. But if it can be anonymous and you can see the entire system, it's a big deal.
So on the transaction for smart contracts, where do you see AI and quantum computing maybe to speed up the latency time?
So that's a good question. Our belief is you really start by getting as much stuff off the chain as you can so it can run cleanly. And then, but I don't think, to your point, SideDB, which is what Hyperledger has, or private collections, that's new in Hyperledger 1.2. We'll have to see how it performs. I think that the DevOps side is very important. What I was talking to Dan about offline earlier was what we would love to see people do is a hybrid model where they've got their own copy at JP Morgan, whatever, but you can drop the workloads onto AWS. Right? And then you scale up if you have a big spike and you need to churn through a lot of stuff, but you've always got your own copy back at the headquarters. So the trick is to try to take advantage of some of these newer things, and I think that you're absolutely right. We're going to see more and more of these special purpose chips. I think none of us really had any, I certainly didn't, I wish I had any knowledge that NVIDIA was going to have so much success in the Bitcoin mining thing off of a chip that they designed for an entirely different market. I don't think we realized that they were going to be as successful as they were in machine learning. Now we've got 20 new machine learning startups, some of them right here. And the question is, are those new chips going to be able to be reconfigured to run blockchain faster? I hope so. You never know. But I think it's going to be a challenge, and we're going to see new blockchain models that are coming out. I would say for all of these blockchain architectures, it's a balancing act. How much security can you stand, and how much can people handle?
Sort of tier level.
Yeah, it's very tricky. We've talked to the US government about this. They want to do blockchain for all the crypto chips now. It's like a meta-style project. And so it's a very interesting project. But their first thought was, we're going to hide it so much, we're not going to know how many chips there are. Right? Not a good answer. Because again, it's bad that the Chinese are going to steal these chips, perhaps. Maybe that's what they're worried about. But if they don't know how many chips are in their own supply chain, they're going to run out. And that's worse. So it's a tricky process. Good question.
In that pharmaceutical example, let's say the FDA decides to go to blockchain for the manufacturers, pharmacies, doctors, and patients. How would they integrate the existing data that's already available, like all the licenses, all of the sensors?
So to your point, what's nice about that particular model, they've already specified the 14 data fields in the DQSA. So the data science is essentially done. They made one mistake. They forgot to add the expire date, and they ask for an expiry block. So, I mean, little miss there, but it's all there, 14 data fields that you need. They've already specified a GS1 barcode. The mistake they made from where we sit is most people are doing what they called it serialization. Big mistake from a crypto standpoint. You want a totally random barcode. You don't want to have 01, 02, 03, because then Lucky Dragon knows to make 05, 06, 07. So you want to have a really robust randomized barcode on that side. A good example is AstraZeneca preprints their barcodes and puts them on the packaging. Again, not optimal, but we'll get there. In terms of what people need, I'll tell you what's fantastic. You know, thanks to Steve Jobs, we've all got a barcode scanner in our pocket now. And so these GS1 barcodes, they scan every time. And so the big question to your point is, do we force the consumer to scan again when they get their package? Or do we just, like the TSA, they get their package at Walgreens and the barcode just drops onto their screen? I would say that's probably okay. My partner Victor would rather see them scan it. It's all a question of managing these security. But at least that part is actually pretty straightforward. The question is how much of a push on the compliance side? I think there are some great ideas out there about how to drive compliance, and the first one is no scan, no warranty, right? If you have no scan, no warranty, that's a quick fix. If you're buying anything over $100, people will scan it to get the warranty. But those are the sorts of things, you know, that we all have to get used to. You know, it's all part of life, you know, but that's there. In other areas, if you've got a supply chain with a lot of things that are under $40, except for baby formula, you're not going to see the compliance you want. With baby formula at $10 a unit, we think you're going to get the compliance because that's what the babies are living on. Their moms will scan it. But anything else under $50, people are a little lazy. I think it's going to be hard to keep that going. Good question now.
You mentioned that hypothecating is a major incentive for blockchain usage. What are the other hot incentives that you are aware of right now for using blockchain? Economic.
So it's a really great question. What we have found is that there are certain things that people think are hot buttons that haven't proven to be quite as compelling when you get down. And one of the biggies that people talk about is counterfeit product. It seems like the enterprises are not as worried about counterfeiting as you'd think. At Louis Vuitton, do they really think that the $100 bag that somebody bought on Canal Street, if they block that, is somebody going to really go to the boutique and spend $2,200 on it? They're not really that sure. And so will they pay, you know, $2 to make sure that that gets run off the street? That's a hard one. What we find is that, and again, everybody's got their own experiences, people are overly trusting of their own employees and their own supply chains, and they're more worried about these imagined bad guys. And in fact, most pilferage and most problems are inside your own four walls. But to your point, hypothecation gets people going because they feel like it's a way to make their relationship with their customers a lot stickier. There's no better customer than a hypothecated customer that's pledged to out his asset because he's stuck with you for life. And the fees are fabulous.
So given that you know hypothecating, I can think is a positive incentive for blockchain, are there things that you're aware of that produce negative incentives for blockchain?
So there's two major negatives in blockchain that I can think of. One is huge, and one is, I think, manageable. There's a lot of talk about IoT everywhere. There's a lot of talk about this, that, and the other thing. And it's all fantastic, but it's not free. So even to put a unique 2D barcode on a product is probably a nickel, probably 7 cents for most people. And to track it on a blockchain is maybe an extra penny. But for a lot of people, that initial 7 cents is a lot of dough. If it's a nut or a bolt, it's very important to you if you're about to fly on an airplane tonight, that all the nuts and bolts are correct. But it's hard for them to justify putting a 7-cent label on a 5-cent bulb.
So are we talking a unique barcode for every single individual item? So if I have 10 identical screws, I'm going to have 10 barcodes for them, one for each?
So that's an awesome question, and I'm going to hedge on that. So when you've got a bottle of Viagra, typically comes 32 a bottle. There's no reason to actually, at this point, now IoT peoples would tell you, let's have a sensor on every pill. And there are a couple of pills that are that way. There's a new one that's out, you may have seen. They actually do have an IoT pill now. But for most people on the Viagra bottle, just having a unique label on the bottle level is fine. Not a big deal. So all 30 come together. It's our job from a blockchain perspective also to do aggregates. So you want to scan the pallet, if it's a full pallet, and know all the barcodes that come with that pallet. But to answer your question in rough terms, yes, you're always tracking a completely unique item. If it's just your normal supermarket barcode where every box of macaroni and cheese is the same, it's not helpful. And if it's not randomized, it's not really that helpful either. So again, if you're trying to protect against a counterfeit, you really need to have a unique randomized barcode. But it's not that hard. A very small barcode can quickly have 6 billion combinations, right? It's not very difficult. But again, you don't want to start with one and count up from there.
Would you please elaborate on the power consumption? And there's a lot of speculation, there's a lot of discussion on that, as far as how much power blockchain really consumes.
Yeah, I mean, I think that all of these things are a trade-off, right?
Yeah.
And so, essentially, I wouldn't say that there's a linear relationship between the quality of the security and the power that's used. But certainly, the belief is that you want to make it harder for the bad guys to break your cryptography. And so if it costs them $30 worth of compute time, and again, I want to say one thing before we get off track here. What makes blockchain special compared to older models is that once you've spent the $30 to decrypt a block, you're no closer to decrypting the second block. Every block is uniquely encrypted, right? And so the key is to make sure that they don't get a leg up. But again, it's one of these things where with blockchain, it's one cell at a time. And so the question is how do you make it hard? Well, you want to make it $30 worth of electricity. And so I think that's where, if there is a Mr. Nakamoto, was one of the brilliant thoughts that he had. It's incredible, really, if you think about it. But I'm sure, and maybe he did have this thought, but I didn't, that once Bitcoin became more and more and more valuable, it makes sense that it's going to cost more and more and more to protect it. And it's worth more and more to go after it. So we'll see what happens there. But again, anything when it comes to progress seems to use more electricity, right?
But in the case of the enterprise applications, you don't see it as an issue.
No, because I don't see it as the issue. And the reason is, I only wish that our enterprise prospects and customers took security as seriously as we did. Very few of them actually want to implement all the security that's available. It's very hard, even the randomized barcodes, which are free, right? It doesn't cost you a penny extra to fully randomize your barcode. It's a free piece of security. But for a warehouseman that's used to starting with 1 and counting 2, 3, 4, that's human nature.